Okay, so this is 2015 FRQ number 2, still in the calculator section. And again, you can probably tell from the graph here, we are dealing with either area and volume or area or volume, right? So that's the beauty of it. All right, so let's take a quick look at this problem. It says, let f and g be the functions defined by f of x equals 1 plus x plus e to the x squared minus 2x. Well, it's a complicated function. And g of x equals x to the fourth minus 6.5 x squared plus 6x plus 2. Let R and S be the two regions enclosed by the graph of f and g shown in the picture above. So you could probably guess which one is which. Again, you have a calculator, so you can definitely graph this out and see which one is which. But let's see. I don't know. Let's see what it looks like. So let's use our calculator. And going back to my functions, well, I'll need it anyway. So, oops, clear. All right, first equation, f of x is 1 plus x plus e to the x squared minus 2x. Oh, that is very beautiful. All right, double check. Again, you always want to double check you wrote everything down correctly, right? Typed everything correctly. X to the fourth, okay, minus 6.5 x squared plus 6x and then plus 2. Okay, all right, let's graph this out. Oh, so you can see this is our function. All right, so for me, that is not helpful because my graphs are the same color. So I'm gonna change one of them to a different color. That way I can see my green is my F and my red is my G. All right, so let me go back and so press graph. There we go. So this looks a lot more like what I have in the test. So it looks like my green is my F and the pink is my G. So F is actually the more parabola-like-ish. And I thought the fourth power would be the parabola, but the fourth power looks like a cubic function. So, okay, this is great. This gives me a great idea of which one is which, okay? Okay, so after seeing the graph on our calculator, we know then that this is f of x. I'm going to use, doesn't matter, but I'm going to use some colors to kind of help me. So this is f of x, and then this one is my g of x. All right, this is g of x. Okay, because again, looking at the area here, and it says it wants to find the sum of the areas, you can see that because of the way the graph intersect each other, you're going to set up two integrals, and you're going to have them alternating between top and bottom. So in the first section here, in the first region here, you have the green on top and blue on the bottom, so you have g minus f. And in the second section, in the S here, you have the blue minus the green, so then you have f minus g. All right, so in your integral for your area, in part A, you're going to say, all right, area equals the first integral being 0 and whatever that intersection is, which we'll go back to graph and look. But it is definitely g of x. So it's going to be g of x minus f of x in the first section, right? And then plus the integral of, does it tell me? Oh, it goes to 2. All right, so something to 2. I don't know what the intersection is, but now the blue is on top, so it's going to be f of x, and then minus g of x, right? And now we need to go back and see what that intersection is, because that's usually why they ask you to do this in the calculator section, because that intersection is something that is decimally, right? So if we go back to our graph here and see where the intersection is, it is intersecting at 1.032. Again, because you're using this in the integral, it is best to keep as many decimals as possible if you can, all right? So either store this or write this down. It really doesn't hurt to write this down so you can have that number, right? Okay, so after looking at the graph, we know that intersection is right here. So usually what I do is I label it on the graph, and it tells you that that x point is 1.3, oh, sorry, not 3, 0.32883188 or 9, all right? So I'm gonna round it there. So I think that's enough decimals. All right, so that's my point. So you can give it a name. Sometimes you can store that number in your calculator, but your answer key typically likes to store it as a variable, but we already have an A here, so I don't know if I want to store it as a variable. It's really kind of up to you. Anyway, so I'm going to put 1.03 blah, 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 and 1.03 blah, blah, blah. That is your intersection point, right? So put this on the calculator, obviously, and you can figure out what the areas are using your Math 9 function, right? So again, if you don't remember how to put that in, check video for the previous FRQ. So 2015 FRQ number 1 will show you how to do that on your calculator. But you should get 0.9974, you know, you get a lot more decimals, but you don't need that much, plus 1.0069, which gives us a total of 2.0043. So total area is about 2.004. Okay, beautiful. All right, part B. Region S is the base of a solid whose cross-section is perpendicular to the x-axis are squares. Find the volume of the solid. So you're looking at region S, right? And again, if you really need to, it doesn't really hurt to do this. You can sort of see this three-dimensionally. So remember, our three-dimensional picture looks something like this. That region S looks something like this. That's your region S, right? And so if this is your x-axis, is y-axis, you're perpendicular to the x-axis, you're running along this way, right? And you have squares, oops, this way, and you have squares going this way. So you can sort of picture what your graph looks like, your shape looks like. But the most important thing is, because it is running along x-axis like this is a dx problem. And then the sides, each side of your square is going to be the top function minus the bottom function, which in our case is going to be f minus g. Okay, so the area of a square is side squared. And each side in this problem is going to be the function f minus the g function, right? This is the top minus bottom in that section, that region of S, right? So for my volume, it is going to be, again, that intersecting point of 1.03 blah, 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 up to 2. And then my functions, f of x minus, oopsies, minus g of x. And this is the whole thing. This is a side, so squared dx, right? That gives you each of the side, right? So that gives you each square, and then you add up infinitely many of these so that you can get all of the squares in this problem. And then you will get a total answer of, and again, plug in a calculator, you will get a total volume of 1.283 cubic units. Again, in the AP test, I don't think it's super duper important to have your units in this case. I think they care a lot more about you being able to take the integral and being able to recognize how to do cross sections and revolution. So in these problems for area and volume, units aren't that important. Okay. All right, part C. Let H be the vertical distance between the graphs of F and G in regions S. This is just a funny way of saying I'm looking for this length right here. So again, it's top minus bottom. That's the region of it, right? Find the rate at which H changes with respect to X when X equals 1.8. Okay, so it says H is a vertical distance. So what is H of X really? Well, H of X is really my top function, f of X, minus the bottom function. I feel like we're just repeating ourselves, right? It's like Twilight Zone. Okay, so it's just the same thing again. So h of x is equal to f of x minus g of x. Okay, but then it says find the rate at which h changes. So again, hint to yourself, anytime you see the word rate, you're taking the derivative. So if I take h prime of x, and this is just a addition or subtraction of functions, you just take the derivative of each. So it's going to be f prime of x minus g prime of x. And when x equals 1.8, so you plug in, you're looking for h prime of 1.8, which really translates to f prime of 1.8 minus g prime of 1.8, right? So for me, I will just go ahead and take the derivative, right? We know how to take derivative. So what is f prime? Well, f prime of x is equal to, well, 1 is 0. This x is being 1. Plus, e to the x squared minus 2x is still e to the x squared minus 2x. But then chain rule, you take the derivative of the exponent, so 2x minus 2. So that is your f prime. all right? And then g prime of x, if I take the derivative, 4x cubed minus that 2 times 6.5, that'll be 13x, and plus 6. All right, plug in 1.8 in each. So f prime of 1.8, and plug it into the calculator. That will give me about 2.11628. More, of course, but I just kind of stopped there. G prime of 1.8 actually stops 5.928. So then if you subtract the two, because h prime is f prime minus g prime, so h prime of 1.8 is really 2.11628 minus 5.928. It's about negative 3.8117. So again, we want to round to 3 decimal places, negative 3.812. That is your rate that h changes. Okay, that's it.